This is me, Matt, a human being, telling you how to reach high availability. I'm going to tell you the story of Algolia. Along the way, you're going to learn a little bit about the company, and most of you are probably already users or have looked at our documentation or something like that. So we won't delve too deeply, but just to let you know, the story we're telling comes from a world where Algolia was deployed to one iPhone. Now we're on 2,000 plus servers, processing 70 billion searches per month globally. So I believe that's about 26,000 queries per second average. It's insane. So that's where we came from, and we're now in over 50 plus data centers. Some more context for you. What do we do? It's a hosted search engine delivered through APIs. So it's got a developer toolkit and a load of features to go with it, like, all the stuff you'd expect: team management, support, solution engineering, analytics, all the fun stuff. If you're not a user already, maybe you haven't seen our logo too much, and that's because, like all APIs, we're kind of under the hood. So we power stuff like Twitch, Lacoste, and Stripe, but unless you're inspecting the network requests, you might not even know we're there, which means we're doing our job well. And to recap what a search engine does, of course it does search, but it also has to handle the data that's searched upon. And that's about the indexing side of things. So we need to handle both very carefully, as you'll see. And you saw a couple of slides ago, we started on an iPhone. That's because originally Algolia was an offline search SDK. So you didn't need an API or an internet connection. And we were able, in fact, to run on the cheapest Android phone. That's a big deal. And our CTO did a great job of building that software because search is quite heavy. It's quite resource consuming. So to do that was quite powerful. However, the opportunity wasn't quite there to scale it as a business. So what they did was they kept the same piece of technology, but deployed it on a cloud infrastructure within an Nginx server. And of course, added some authentication along the way. It wasn't highly available at that stage, but they kind of knew how to do it. The biggest decision at that stage was making the move of not going to virtual machines, but instead using bare metal servers. One of the reasons for that was because the resources required for what they were trying to do with search, they were quite heavy, as we said. And the cost of doing that with some cloud providers was insane. However, if they went for bare metal servers, meaning physical hardware that Algolia owns and manages, then they could begin to achieve much higher availability at a lower cost, which is, what everyone wants at the end of the day. So that's where we were 2013. And what we're going to show you is our journey in that model to try and get to high availability. And by no means is it easy for any API I've interacted with. I'm sure if you've used or run your own, you know yourself, this is not an easy thing to do. Let's learn from some of the mistakes that happen along the way. When I say mistakes, I don't mean purposeful mistakes. I just mean things that you learn from as you begin to scale out the service. Worth reminding us what we're concerned about here, and it's high availability, essentially meaning that it's always up, always available. It does not fail you. Whenever there's a search bar powered by Algolia in an app or a website, you are always able to type, always able to receive results. That's what we're aiming for. What we'll do is show you this journey through the analogy of Mad Max's Fury Road. Let's go. So first of all, we had quite a reasonable car. Let's put it that way. It wasn't terrible. It was a good piece of technology ready to be deployed. And it was about to try and drive across a really tough, unpredictable environment. And let's see what happened when it tried. Starts out, of course, everything is working well, as you think it always is. And then the server crashes. Do you remember it was on a single machine? And a single machine cannot deliver high availability. Simple as that. You need to deal with faulty servers. So the first thing that happened is we did master replication from 1 to 3 servers. essentially replicating the whole engine. Each of those servers holds the full data, and each of them can handle both indexing and search operations. So if one machine fails, we have two others to take over. Great first step. Here are some of the specs of the machines if you're interested. Reasonably powerful. Back we go, we're working well again. So now 3 machines, master replication. What next? We have a search operation, and something can happen in the middle of processing it on one of the 3 machines. What do? Well, this decision was interesting because you could have tried to solve it using a load balancer, but that would have meant a single point of failure. So what the team actually did was implement some logic in our API clients that we ask our customers to use in order to communicate with the API. What this logic does is that during an API call, if one machine fails, then the logic will retry it on another of the 3 machines. Not too bad. And another one, indexing operations. So we talked quite a lot so far about search, making sure that search operations succeed and that nothing crashes while they're doing so. However, sometimes that isn't the bulk of the operations that are needed to handle it, especially during a spike. Indexing operations doesn't depend on user traffic. It depends on your own updates to your data that's being searched upon. So things like deletions, additions, updates. That is important because if you're doing a batch job, it can consume a lot of resources. And if it cannibalizes all of the hardware resources available, search performance can be impacted. So fairly obviously, what you'd rather do is not degrade search, but degrade indexing operations. At least delay them and accept slightly less fresh content, but still have your search up and running, right? So that's what we did. What we did was prioritize the reads over the writes through configuration in the IO scheduler, which meant that we were prioritizing searches over the indexing operations. Big help there. You always want to do that. Search should always be up. It doesn't matter to that extent if your data is slightly less fresh, because it's better than search being down or degraded. Some improvements. We're looking quite good at this stage. However, things start to get tricky. The whole rack can go down. So you remember we said we had 3 machines? Well, those 3 machines can also go down, or the network connectivity connecting those machines can go down. And I did not think this happened as much as it does. Not that it happens every day, of course, but it does happen, and it has dramatic effects. So 60 seconds of downtime, even upgrading the network switch, that's a lot. It's unacceptable. So what the team did was use multi-availability zones. We made sure that for each set of 3 machines, that none of them shared the same network equipment. So we had redundancy there. Everything's working well. And this car, if you don't mind me saying, is looking pretty souped up right now. We're not done by a long shot. The whole provider can go down. So, you know, once again, it doesn't happen every other week, and especially in Europe and the US, you should be able to rely, very heavily on each provider. But it does happen worldwide. And so there have been times when we have suffered an outage and had to deal with it. The obvious solution, adding a second data center provider. So each set of 3 machines, they have 2 relying on one provider and one other relying on a second provider. So this helps a lot with the extra layer of redundancy. Quite the list we're growing. Now we have a growth problem. So we have some good redundancy, but then we have more customers, and those customers are global. And you can imagine for an Australian customer, trying to reach an API hosted in the East Coast of the US, that's a bit of a problem, and it's not going to be fixed by the internet itself. It can be fixed by bringing the data closer to the user, so you can guess what's coming next. We replicated things again. We replicated the engine across the globe. So as a customer, you can choose all of the regions that you want your search engine replicated in across the globe. I'll show you this here. I think today we offer about 16 different regions you can pick from to replicate your search engine. Now, in addition to this, we also use a geo-aware DNS provider to make sure that the API clients target, firstly, the data center that's closest to you. So hopefully the Australian customer would be then reaching the data center in Sydney, for example, instead of trying to cross continents and oceans. Good stuff. Now we have another growth problem. Queries are growing. So our customer base grew, we became global, and now our query load is growing. So until it's Black Friday and some of your customers start having huge spikes, and by huge spikes, by the way, we're saying like 100 times more traffic than normal. Well, apart from that, the average processing time of a query within an Algolia machine is about 10 milliseconds. That's really good. But the bare metal servers can only handle as much as they have CPU available. So that's a bit of a problem. But some of the way in which this has been architected has helped us solve it because we're able to horizontally scale. So that worldwide replication mechanism means that you can use it to increase a region's query throughput. So you can scale your searches horizontally. The more replicates you add, the more CPUs you have available to answer searches. You can still leverage the load balancing features of the API clients to do that. So you can see here, we've got quite a few machines on, I think, is it the East Coast there? And quite a few clustered in Europe, the main regions for business, and then a few replicants around in different regions. Back we go. Uh-oh. So you can see where we're going with this. Everything that can fail will fail at some stage. That's the theme. And you can, of course, take it to the nth degree and try to reach as close as you can. You can add redundancy forever and ever and ever and keep going. But what we had to do in this case is acknowledge the fact that we had a DNS provider, which is down. And, you know, it's not something you expect to happen. And it can screw your entire company because if the DNS is down, then your service is not accessible. So in that case, the obvious thing to do is get a fallback DNS. So you got algolia.net or algolianet.com, I believe, two different domain name service providers. A tip from Sylvain, our VP here, is to be using .com or .net, not something like AI or IO, because for those AI and .io and those kind of smaller top-level domains or more exotic domains, there aren't so many root DNS servers able to handle the requests, and they can get overloaded easier. Less of the case for things like established.com and .net. Progress until the two data center providers are down. And so, yes, it also actually happens. More cowbell, more data center providers. I believe in this case, we're currently dealing with about 12 providers around the world, if not more. And of course, it's not easy to manage, but it's the only way at this stage to reach 5 nines. So you got that extra 9 on there. I'm going to stop here for a second just to acknowledge that you could keep doing this to infinity. You could keep adding improvements to your car, keep going and going and going, but it's completely dependent on, you know, how many 9s you need. At the moment, we're talking about 5, and this is the list that helps get us there. So we thought we're finally ready. Now we have a different kind of problem. We had potentially an unbalanced amount of machines performing requests, and that's because certain machines could perform way more than others, like a million requests. So if we have a customer that's sending a million requests from a single machine for whatever reason, the API clients are not that good at balancing it. And so we had a bit of a problem. In this case, it did make sense to add a load balancer in front of those big deployments, making sure that customers can achieve the best kind of load balancing, no matter what way they're querying the API, whether it's from many or all from one machine. Important addition, but only for those deployments where it mattered. Here's our list. The API itself is now fast, highly available, and worldwide distributed, using its own bare metal servers optimized for search. But there's one thing left. You'll see that we have the product highly available, but now we have data and ecosystem around the product. We have backups, analytics, logs, and the compliance around this, as you know, is that some customers will need everything in the one place. So whether it's trying to restore machines of, let's say, backups, where you have machines in Australia and the backups in the US, for example, or whether it's compliance and you just have a requirement for a customer where everything should be in one place, like Europe, Germany, for example, then we needed to handle that. And so we do. And fresh lick of paint, looking good there so far. Car, in fact, is finished. But here you see there's no one driving it. And that is the final addition to make here, human pairing. Because no matter what you do with your product, there's still a way to blow it up, and that's people making changes in production. And of course, it's not about the people themselves. It's about having a safe process to protect you. No one is infallible. So having more than one pair of eyes, at least two, on every change that could affect something, whether it's a code review or an infrastructure update, and of course deployment, that gives you that extra layer of security and comfort that you need for your business to be confident. Ready to go. That's part of the journey that we went through, and it was really nice to be able to share it with you. I'm going to stop now, and I'm happy to answer any questions, or at least attempt to, and if I don't have the answers, I will certainly get them to you. But I want to say thank you very much and hand it over to Jamie Barton.